Here we have a question on the topic of recursion and ADT list. So here we have a method called isPalindrome that takes a list of characters that we call it list. And before debugging the code block, let's actually look at our options here. So we're asked, based on this code block, what will the output of this code? So we're looking for the output of this code. Either it be true, false. Okay, so we're looking for some Boolean value, or it throws an error or an infinite loop. So we have basically two out. Either throws a Boolean, and by throw I mean it outputs a Boolean, or does not function properly. So we need to check whether this functions or not. If it doesn't function, then it's one of our two orange values. If it does function, it's one of our two red values. Focusing on this program here. And we'll go line by line as if we were the Java compiler. So now Java compiler sees that you're making a new public static method called isPalindrome. Now what this means for us from the first line, that we have a public method, meaning that it is accessible by basically everyone from the package or subclasses or superclasses. It is completely public. By static, we specify that it does not need to be instantiated, okay, to function. And then we say that a return function is a Boolean. Now immediately you might say, okay, well, we say it's Boolean, but it's one of our two red values. But of course, an error is still possible. So we can immediately move to removing two options. Okay, so public means it's accessible by all, and I put in quotations just to specify that that's not really a formal way of saying it, but it'll suffice. And by static, we mean to express that does not, okay, so it does not need to be instantiated. Instantiate. And Boolean, you understand what that is. So we call our method isPalindrome, and it takes in a argument, and its only parameter is a list of characters, and we called it list. So we take this list and immediately check if it's less than size 1, then of course it's a palindrome. Because of course, if we take for example, the letter A, it is of course palindrome because it is the same forwards and back. Now we have another case. Otherwise, if we get our first value and it is not equal to the last value, then immediately we know it's false. Like for example, if you had a robot. Of course, this cannot be a palindrome because these two values are not the same. Right? There's no further detecting for us to do, right? We can immediately say, okay, well, there's no point in wasting hardware and computation, right? We already know it can't be a palindrome because it cannot be the same forwards and backwards if it doesn't even begin and end with the same letter. So that's that's smart. Everything we've seen so far is pretty smart. So now let's get to that recursive state. This is where we need to see if anything goes wrong. So here we say that we remove our 0th or first element, then remove the last, and then we want to return this new updated list. So let's sort of see how this functions. If we took, of course, we can look at the example it gave us. If we took car, okay, so what it would do is it would take this, then it delete the first and last value, and then we get left with ace CA. Okay, then it checks if the first and last are not the same or the same. All right, in this case they are. So it moves to the next stage, deletes these two. Then we have CEC, third stage. It checks whether these are the same. Okay, so I'm following the logic. First it checks whether it's less than 1 in size, and then it checks whether the first and last character are the same. So let me go over this one more time. Of course, this is not less than 1 in size, so that works. It also has the same first and last letter, that works. The same goes for this, same first and last, less than or greater than 1 size, same for here. And now we hit that point where it's equal to 1 in size. That's checked. So now when we get to this point, we remove the first and last value, which is just this point, and then we get an empty list. So I'm going to call this null. Now what does the program do? Here is the issue. This program does not foresee any null values. It doesn't know what to do when it's null. Okay? So we know that our list is actually of size 0. So we have no characters in our list, thus we know to stop. However, because a 0 item list passes both this test and this test, we move on to this else case, infinite amount case. So let's see our options. We know this doesn't function properly, so it can't be either of these. Now what can we do? It either enters an infinite loop or throws an unsupported operation except. Okay, so what do we do? Let's first check what an unsupported operation exception really is. Alright, so this is the very in-depth and formal explanation. But really you need to know that the unsupported operation exception occurs when we try to attempt to do something or attempt to execute a method that has not been implemented by some certain class. So let's look here. Everything we've done so far, like list.size, list.get, list.remove, these are all valid operations. Okay, so let's highlight them here. These are all valid operations in terms of the list class, right? The list implementation supports all of these. Alright, so we basically know this cannot be it. And now you might say, okay, well, that's not fair. The fact that we're giving it a empty list means that we're trying to make it do something it's not capable of doing. That logic and reasoning is sort of correct. However, giving an empty list is not the same as calling a method that does not exist. Okay, so giving it an empty list is sort of dysfunctional programming, but calling a method that does not exist is an error on the user's part, not the Java compiler or the Java methods part. It's an issue in terms of the user because they don't fully understand how the class they are using functions. However, giving it an invalid input, of course, is the fault of the user, but can also be the fault of the method in terms of specifically recursive functions. So the final option that is valid would be D. It enters an infinite loop because we get this null state, and this null state is never escaped because our function doesn't know how to handle when it's done. It doesn't even know when it's, sorry, never mind. This null state is never reached because we actually get to less than or equal to 1, and this immediately returns true. Okay, so we don't actually have a dysfunctional program. I just didn't understand it. So we do indeed get true because when we get this one letter E, this is of course suiting this condition. And because it suits that condition, we immediately return true with no recursive step. Okay, so we never get to this recursive part, thus our recursive tree breaks, and thus we get true. Hopefully that helps.